how does one choose an appropriate sample size, or let's say the number of trials, when one is interested in estimating a population proportion? Well, there are a number of different ways to do it, but when you're purely interested in trying to get at that population proportion pi, what one does is as follows. One looks at how close your sample estimate, the proportion of, let's say, successes that were observed in the sample, how close is it to the corresponding population proportion? So when I take the absolute value of pi hat minus pi, I'm getting a measure of closeness. And what one tries to do is choose a sample size such that pi hat is close enough to pi, and that closeness is less than or equal to some number e. So for example, I could say I want to choose a sample size such that pi hat minus pi is less than or equal to 3% or 0.03. This 0.03 or E in general is often referred to as the margin of error. Now, one of the big places where this kind of choice for a sample size is done and a margin of error is stated is with respect to political polls. So this little subsection of the notes will tailor the discussion towards political polls. Okay. So the sample size used to estimate pi and to have an approximate 1 minus alpha times 100% confidence that pi hat is within, let's say, E units of pi, that sample size should be chosen in the following manner. Your sample size n is equal to a quantile from the standard normal distribution squared times pi times 1 minus pi over the error squared, this margin of error squared. Well, where does this expression then come from? Well, we've seen earlier that I could take an approximate standard normal random variable with respect to this statistic pi hat that estimates then the population proportion, and I'm writing in terms of the random variable way. That random variable then, we'll call the whole thing here z, capital Z. You can put that between two quantiles from a standard normal distribution, and the corresponding probability of observing a particular C is approximately 1 minus alpha. Now let me do some erasing here. Well, how about we look at, instead of the random variable version of pi hat, how about we look at then the observed value itself? Then we set that quantity of the absolute value of pi hat minus pi equal to error, our margin of error. Then we can essentially put that error now in the numerator of our quantity that we were having up here when we were writing in terms of random variables. Also, sorry, I should have mentioned this to begin with too, just in case it's not clear. I could put an absolute value here and remove that portion there because of the symmetry property of the standard normal. Now, by putting E here, I still have this pi times 1 minus pi divided by n. How about we set this equal to that quantile from the standard normal, in other words, this right there. And then from there, solve for n. And if we do that, this is how we get this sample size expression. Okay. Now, hopefully, as I was going through this, you were thinking, well, wait a second here. You want me to calculate, well, what the appropriate sample size would be to estimate pi, but don't I need to know what pi is first in order to come up with this expression? Well, yes, sort of. So the problem is, well, what is pi? And so what's done then in practice is a conservative solution is used in this expression when coming up with this sample size. So what this conservative solution is that let's pick a pi that's going to maximize pi times 1 minus pi in our expression for n. So let's come back here. So if I find a pi, or if I use a pi, that makes this as big as possible, what that's going to mean, since it's in the numerator, it's going to make n as big as possible for a fixed e, for a fixed confidence level. This is then a conservative solution because some other n could work too that's smaller if that pi was something else. So what we're going to do is choose, let's say, the largest n that would be necessary in order to still remain 1 minus alpha times 100% confident. Okay. So what is then this, this choice of pi that maximizes pi times 1 minus pi? Well, what I did here, I constructed a table. I started plugging in values of pi. And what you can see is eventually once we get to 0.5, the maximum value of pi times 1 minus pi is 0.25. So the conservative solution is always to use pi equal to 0.5 in that expression. And so what this means is that what we're going to do now is restate our expression for what the sample size should be. And we can be at least now 100 or 1 minus times 100% confident that the error will not exceed a specified amount e when the sample size is chosen to be as follows. Quantile from the standard normal, plug in 0.5 for pi, and then state your error. That's how you would use then this expression. So let's take a look at an example. So this again deals with political polls. Suppose you want to determine the percentage of registered voters who will vote for the Republican or Democratic nominee in a presidential election. How large of a sample should be taken so that the margin of error is less than plus or minus 3.5%? So what that means is you want E to be 3.5%. In other words, you want pi hat, which would be the observed number or the observed proportion of people who will vote for, let's say, the Republican. You want that to be within 3.5 percentage points of what the true value actually is in the entire population. So with this setup here, and notice the confidence level as well, we put in alpha equal 0.05 for our quantile from a standard norm. We've done that many times before. Use the Q norm function to find that. We get 1.96. I square it times 0.5 times 1 minus 0.5. I put my margin of error in the bottom, square that, and I get a sample size of 784. Now, very often when you use this kind of an expression, you'll get some kind of decimal value after that. And if that's the case, just go up to the next highest integer. Okay, so here's a very important question that here, and we often see this in the media whenever we see a political poll being taken and then the results being displayed, and we're often faced with a situation of actually interpreting what this is. Sometimes the people in the media get it right, sometimes unfortunately they don't get it right. So let's say a poll was taken and the Democratic nominee had 51% and the Republican nominee had 49%. So in this particular situation, maybe, again, pi hat is the Republican proportion. I could have easily just said Democrat as well. It doesn't matter. So the question then is, well, who's winning the election at this moment in time? So, in terms of the population then represents, let's say, all the people who will actually vote. A sample was taken of, let's say, 784 people, and 51% said Democrat, 49% said Republican. but the margin of error is 3.5%. So what that means then is that I could take that 3.5% and add that to what the Democratic value is, or I could do it Republican, doesn't matter, get 54.5. So the Democrat could be actually up to 54.5, or I could subtract it, because remember it's plus or minus. And in that case, I would get 47.5. So the Democrat's somewhere between there. Now for the corresponding then Republican, so this is Democrat down here. Now for the corresponding Republican, let's go up here. When the Democrat's at 54.5%, well, that means then the Republican is 45.5%. When the Democrat's at 47.5%, that means then the Republican is 52.5%. So based upon this political poll, who's actually leading in terms of if the election was conducted today, who would win? That's what we're after here, so that we would know what pie, the proportion that will vote, let's say Republican, would be. In this particular case, we can see because of this margin of error, we cannot say one particular candidate is beating the other. Right now, there is not sufficient evidence to say that one is leading than the other. And then, let's see, on this would be the top of page 4. And this is what I'm getting at then with respect to this note about the margin of error. Just even, outside of doing whatever your research is, understanding what this margin of error means in terms of a political poll is extremely important. Here's another example. So this was back when I was in grad school. I was watching the news one night, and it was Bill Clinton versus Bob Dole in the 1996 presidential race. And there were two polls that were taken by a TV network right before and right after Bob Dole chose his running mate, his vice presidential candidate. Here are the results. So before the choice was made, Clinton was at 53% in a particular poll, then Dole was 37%. After the vice president, in this case was Jack Kemp, was chosen, the nominee that is, Clinton was 52% in a new poll. Dole was 39%. So after presenting the results of both polls, a TV news anchor person said, Kemp has helped Dole in the presidential race. Well, unfortunately, and this is often what happens too, a margin of error was not stated. But often in these kinds of polls, it might be 3%, 4%. So let's say it's 4%. Okay. So, what do you think about this statement? Has Kemp really helped? And it all comes back to this margin of error. So, before, Dole could have been as high as 41% in terms of the population proportion of people that would vote for him. It could all the way be down to 33% as well. Now, after the poll was taken, Dole could be at 43% or all the way down to 35%. So we see this overlap between these two ranges. So can we actually say that this choice of Jack Kemp has helped? Well, no, because we know this true proportion of people actually overlaps between the two different situations. Now, something else. We've been talking about confidence level. So back when I stated what this n should be, we had a 1 minus alpha times 100% confidence level, similar to what we've had with confidence intervals in the past. What I find strange and I guess somewhat disappointing is very rarely in any kind of political poll will you ever hear stated also the confidence level. Sometimes you hear about the margin of error, but rarely about the confidence level. And this is important. We've seen what that confidence level means in terms of a confidence interval. What does it mean in this particular situation here? Here's a nice example of what it means. And this is an old example, but I've never found an example that's any better than this one. And in the way that that with this political poll, the newspaper explained the statistics behind it was excellent. So this involves the Nebraska Senate race in 1996 between Chuck Hagel and Ben Nelson. And the Omaha World Herald had a survey conducted, or a political poll conducted, to see who was winning the race. And this was in late October for the November general election. And at this time, Ben Nelson polled at 49%. Chuck Hagel polled at 44%. In the end, Hagel won the actual election, which was a few weeks later. Okay. And so I urge you to take the time to read the corresponding newspaper article here. As you can see, it was so old that I actually have it scanned in rather than having an actual web link to the actual article itself and printed it from the internet. And so if we tilt our heads here, we can see the summary information for the poll. Notice that the margin of error was 3.4%. Okay. So let's use an E of 3.4% in our equation that we looked at before. So n is equal to, and we're going to use 95% because they actually did state a confidence level here. It was 95%. So similar to what we had before, 1.96 squared times 0.5 times 1 minus pi, 0.5 I mean, all that over 0.034 squared, you get approximately 831. Note, though, that they actually use 1,006 people in their survey. So you might be wondering, well, wait a second. Why do they actually sample more people with this margin of error and this confidence level? And the reason is because how they actually went about doing their political poll was a little bit more complicated than how we're doing it, how we've talked about it in this class. If you remember way back early in the semester, I said, well, we're only going to concentrate on random samples. Perhaps I should have mentioned this at the beginning of this section here. What we're doing here in terms of finding the sample size is for a random sample. There are a lot of other more fancier sampling techniques that one could use. And with these fancier sampling techniques, this will cause the sample size needed to go up to still have a particular confidence level and a particular margin of error. If you want to know more about those techniques, you can take a whole class on sampling. But in summary, what they did was the way that they took their sample was basically somewhat like a stratified random sample. So at this time, Nebraska had 3 congressional districts. And so they ended up taking a larger sample in one of the congressional districts than some other ones. They also then did some weighting of the people that were included in their survey so that they could get an accurate representation of the actual voting base for people in Nebraska. So perhaps in their sample, maybe they had a larger proportion than what you would expect of 18 to 29 years old, 9-year-olds in terms of who actually votes in Nebraska. And so what they could do is actually downweight those people who voted in the poll a little bit. And when you do all that, that changes what your sample size, what your margin of error would be, without going into all the details. Okay. So that's how that comes about. Now, really the cool thing in this example was this. Here's how the World Herald, Omaha World Herald, which the newspaper, poll was conducted. Let's go through this. So first of all, they define their population of people that they're taking the poll for. So adults 18 or older, because of the voting age, who live in Nebraska, and identify them as registered voters. Maybe they should also look more into likely registered voters, because just because you're registered doesn't mean that you actually vote. So the poll was done based upon telephone interviews, commonly done. 1,006 registered voters. It was done by the Gallup organization. which says from Princeton, New Jersey, but their current really main corporate headquarters is actually in Omaha. And so the problem with polling is, you might try to get somebody to respond to tell you who they're going to vote for, and sometimes it may be difficult to actually reach that person. So what they did was they did multiple attempts to call these people to get their get information about who they would vote for, and there is kind of a random sampling inside all this in terms of they use a random digit dialing of phone numbers. We can see how they did this unequal weighting of people from the different congressional districts, or in terms of the sample size from each congressional district. And you can see that a statistical specialist at Gallup was used to ensure that each congressional district's representation in the sample was proportionate to the population. So a weighting process was used to ensure appropriate representation by age, sex, education, and race. So if you ended up, let's say, having a large proportion of people who are college educated, larger than what would be in the general registered voter population, then again you would downweight those responses some. Okay, now here's the really good stuff. The poll's statistical margin of error based on the entire sample 1006 was plus or minus 3.4 percentage points. That's our E. And notice here, they say, and at a confidence level of 95%. Now, such a sampling error means that if the survey were repeated 20 times, the results would be within 3.4 percentage point range, plus or minus 19 times. And they should say on average. So what that means is as follows. Let's say pi represents the proportion that will vote for Chuck Hagel. Okay. Now if they go out, take a sample, calculate pi hat. Go out, take a sample, calculate pi hat. And suppose they did this 20 times. And what you would expect is pi hat's going to vary from one sample to the next. And let's say somehow we ended up actually knowing pi. Then we would expect 19 of those 20 times that this difference between pi hat and pi in absolute value should be less than or equal to 0.034. On average, we would expect this to happen 19 out of 20 times. Very frequently in our class, I talk about, let's say, if we repeated the sampling process 1,000 times. Well, if we did that here, that would mean about 950 times on average, we would expect this difference here to be within 3.4 percentage points. And like I said, it was, when I saw this, I was like, wow, this is really cool that they actually mention this, and rarely ever do you see this mentioned. I think in my career as being a statistician, I've seen this in the media maybe 2 or 3 other times actually represented. I mean, I often like it. I mean, I often really like the fact that some polls or some political polls will mention the margin of error, and that's great. I'm glad that they're doing that. But they need to go a step farther and also mention the confidence level too. Okay. So some final comments. Well, what about polls that are conducted on the internet? And what I'm talking about is, let's say if you go to a website and it says, okay, what's your opinion on something? Click here if your opinion is maybe yes. Click here if your opinion's no. Those kinds of polls are worthless. They're not, let's say, a random sample from a population. The sampling process is biased based upon the people that go to that website. Another final comment is, what about, sometimes you see non-scientific polls. If you ever see that phrase non-scientific, just ignore it. That would be equivalent to me, let's say, going and ask my friends their opinion on something. Since they're my friends, they could be biased a certain way versus another. And so non-scientific polls are completely worthless. Please ignore those. Okay, So that concludes this section on how to choose an appropriate sample size. There's a lot of things in our everyday life in terms of like the political polling that we see in the media that corresponds to what we're doing here. And I hope you found this section to be interesting because of that.